Hey guys, so for the next few lessons, we're going to be focused on circles. We've sort of pulled out the highlights of what would have been our circle chapter had we still been in the classroom, just to sort of pull out the things that might appear in following classes or might appear on something like your SATs, so that hopefully, should you see these things again, it's not completely new. So we're just going to start off with some vocab. So a circle, you should have this idea in your head, obviously, what a circle looks like. But by definition, it is all points that are the same distance from a given point called the center. Okay, that center of your circle is also actually how a circle is named. So if you look at your picture here, this center point, if I had given that, say, point C, then this would be circle C. A chord is a segment with endpoints on the circle, and hopefully you can see I kind of color-coded things for you. A diameter is considered a chord, but it is the one that specifically passes through that center of your circle. Okay. And a radius is a segment that has the center of the circle and a point on the circle as endpoints. So the radius is 1/2 the diameter. So yes, I could have labeled, say, just the left or just the right side of the diameter as a radius, or you can have a radius that isn't technically part of the diameter, or it could be if you kept drawing it. So this relationship between a radius and a diameter is sort of our first focus. So it says C, F, and G are centers of circles. Find the following values if CB is 20. So I'm just going to, let's put some color on here. 20 is what they gave me for CB, so here's 20, right? So what you should notice is we have multiple circles in this picture. There's the big circle, medium circle, and small circle. So C is the center of the big circle, F is the center of the medium, and G is the center of the small. So what happens is if we use this relationship between a radius and a diameter, 20 is the radius of my big circle, which means if this left side is 20, this right side would be 20. But that 20, if you notice, goes from C to E, meaning it's the entire way across the medium circle. So if I take 20 and I divide it, I get 10. So now half of that is 10. Well, if this side is 10, so is the right side. And that means that that 10 again is being split into sort of those two equal pieces. And so if I put those on my picture, now I have a whole bunch of segments that are labeled. And so that can help me answer the questions they've asked. They asked me to find the length of CF. Well, when I look at my picture, CF was the radius of that medium circle, so CF is 10. FE, that's the whole way across the small circle. It's also technically a radius of the medium as well, so FE is also 10. FG, when you look at our picture, that's going to be the radius of this small circle, so that's going to be 5. And then CD, well, CD is just another radius of the big circle. So if CB was 20, CD would also have to be 20. So we're using that relationship. If I know the length of a diameter, I can divide it by 2. That gets me the length of a radius. Okay, they could have had you put pieces together. They could ask for something like, well, how far is it from C to G? And so 10 plus 5 would make 15. Okay, those types of things are also possible. They don't have to just be a radius or a diameter. You might have to combine some of those pieces. Let's look at a little bit more vocab, something called a central angle. So picture-wise, it might look something like this. Definition has the center of the circle as its vertex and 2 radii as sides. So central angle literally means an angle at the center of a circle. All of the central angles of a circle add up to 360 degrees. So if I break this up like a pizza into a bunch of slices, all of those slices together have to be 360 degrees. A central angle does split the circle into two parts, each of which is an arc. Technically, the circle is just sort of this curved black line and not necessarily all the space that's considered inside the circle. So an arc is the part of the curved black line, say from A to C in my picture. That's if I'm going around, say, clockwise. I could go around counterclockwise, and that would be the other arc to my circle. Okay. So let's look a little bit at those arcs. So we've got, again, just some vocab. If you look across the top, there is a minor arc, a major arc, and a semicircle. And if you look down the side for each one, we're going to look at what technically is the definition, an example of what it looks like, how we name them, and also what they measure. So we'll take the minor arc first. A minor arc is an arc that measures less than 180 degrees. So think of minor as being small. Might look something like this. If you have a central angle, oftentimes what they'll do is they will label the angle, okay, with that measurement. When you name it, you're going to use the letters of the two endpoints, and it will have this measure that's the same as the central angle that you're looking at. So for example, in this picture, okay, I would say that I have arc AC. So I would use the letters from A to C. We use an arc symbol over top, much like when we write segments, we use a little segment line. Here we need a little arc symbol. And it's simply going to equal the same 110 degrees that the angle is, okay? I can say arc AC or I can say arc CA, like segments that works forwards or backwards. Your major arc is an arc that measures greater than 180 degrees. But when you look at the picture, notice that what they labeled is something that's smaller. They labeled a 60-degree angle. That's going to be normal. In order to name a major arc, you're going to use the letters of the endpoints and another point on the arc. Because if I just use the endpoints, say ED, ED would be the small minor arc. I need to know that I need to go the long way around the circle from E to F to D. So that means I'm going to have to use F in the middle to say, hey, take the long way around. They will often label with the measurement the small piece, because if they fill in this large piece, where do they put it so that you know that it belongs to the whole thing? It's a lot easier to label the small pie piece. So oftentimes to find the measurement, you're just going to need to do 360 minus that minor arc, meaning subtract the small part you don't want. Think of it like a Pac-Man, right? Subtract the mouth away, you want the whole body of the Pac-Man. So if I were to name this, let me put a little space underneath it here, okay? In this case, we're going to want EFD, like I said, we're going to need all three letters. Using 2 or 3 letters is also a good way so that even when you just look at the name of something, you know its size, right? So here's my arc symbol. And in this case, if a whole circle is 360, 360 minus 60 would mean this has a measurement of 300 degrees. So a minor arc is less than 180. A major arc is more than 180. And that leaves us with a semicircle. A semicircle is exactly 180 degrees. If you look at the picture, a semicircle is going to be made using a diameter. So anytime you have a diameter going through that center point, you actually are getting 2 semicircles. Each one is 180 degrees. Like a major arc, you're going to use the endpoints and you're going to put another letter in the middle. That way we know Do I want to go from J to K to L? Or am I going JML? Which semicircle do you want? Say the top or the bottom. But they are all going to be exactly 180 degrees. So I can have JML, for example, or I could have said JKL. Again, give it an arc symbol, equal sign, and 180 degrees. Okay. So now what we want to do is we want to take this vocab, right? We want to take the idea of a central angle. We want to take these arcs, and we actually want to do some examples with finding those measurements. And so that's what the next video is going to be, are the examples using this vocab.